Okay, so this is the second part of Module 4, Lesson 26, and now the only difference is instead of an addition equation, now we have a subtraction equation. So first, let's just think, what number would make this work? What number would make this work? How about 10? Let's try 10. If I do 10, would that be a solution to this equation? No, because that is false. Well, let's try 11. If I try 11, would that be a solution to the equation? No, that's still false. So it looks like I need one more, probably 12 will work. Let me talk you through how we're going to show this algebraically. Now here's our original equation. Just like last time, my goal is still to get the variables by themselves. So I want this to somehow change into just d. That's all I want it to change into. So what could I do with d minus 5, right? If I have this. What could I do with d minus 5 to get it back to just the variable d? Of course, you would add 5. So that's what I'm going to do to both sides of my expression here. So I'm going to do d minus 5, but I'm also going to add 5. But now this equal sign tells me that this side is the same as that side. So I have to do the exact same thing to the other side. So I added 5 here, so I need to add 5 over there. And so now we know d minus 5 plus 5, we've already said that equals d, and 7 plus 5, that equals 12. And of course we know that's correct, we can check it just like this. 12 minus 5 equals 7. Does this solution make a true statement? Absolutely. 12 minus 5 is 7, and of course that's true. So we have our solution is d equals 12, and we've shown our very important step of plus 5 to both sides. Now, you might already have the hang of this from the last video. So here's your next equation, another subtraction equation. Notice how I don't say a tape diagram. I just want you to now try this algebraically. No more pictures. Let's see what you can do. So here's your equation. Try to solve it, showing steps just like this. Try it on your own. Come back. Who knows? Maybe you'll get it right. Okay, so what am I going to do? I want x minus 8. I want that to somehow get back to being just x. So what could I do with x minus 8 to get back? I could add 8. That would get me to where I need to be. So I have x minus 8 plus 8. I know that's going to equal x, but let's pay attention to our other side. Remember, we have to keep it balanced. If I add 8 to one side, I have to balance my equation. I have to add 8 to my other side. I keep referencing a balance scale. It's this kind of thing. If I have something like this, right? When they're like this means they're equal. But the second one of them tips, right? When it tips, now they are not equal. Because if you put something over here, that's going to make it go down, and it's going to make that side go up. It's heavier. We have to make sure they stay equal. So 10 plus 8, 18, and there's our solution. Let's check and see if it's right. So here's my original equation. Let's check and see if this makes a solution. 18 goes in place of x. We're saying that's what x is equal to. And 18 minus 8 is 10. And of course, 10 does equal 10. So that's your second try. Now let's try it a third time. So here's a third time. Again, trying to solve it algebraically. The only difference is I kind of flipped it around and you think about how you could solve this one. Pause, try it on your own, come back when you're ready. All right, so I've got m minus 3. What's my goal in all of this? My goal is always to get my variable m by itself. By itself. That's very important. So eventually I want it to say m equals something. So if I think about it like the do now, right? How can I make m minus 3 get to just m? I can add 3. If I do that, it's going to be m minus 3 plus 3. We know that equals m. Remember, we're evaluating down, not across. And so then I have to, if I do something to one side of my balance scale, I have to do something to the other. So I'm going to do plus 3 over here. And of course, 9 plus 3 is 12. I can check it by substituting, but let's just go ahead and move on and save ourselves some time. Let's trust ourselves and say, okay, well, we're pretty confident in our equation solving with these really basic numbers. All right, so now let's see what you can do. Just like we did with addition equations, I want you to try to solve this equation in this space, then check your answer, and then see if you can fill in these sentences down here about describing how you solve subtraction equations. All right, so you should be back from pausing your video. Let's see if we can solve this. Remember, my goal is to get this W all alone. So I'm thinking of it like this, W minus 102. How do I get that so it's back equal to W all by itself? Well, we know we're going to add 102. So I'm going to do that to both sides. I'm going to do W minus 102 plus 102. I know that'll give me W, but I have to think about the other side of my equation. That means I have 180 plus 102. Oh, I better work this one out. If I have 180 plus 102, let's see what I get. 2 and 0 is 2, 8 and 0 is 8, 282. So W must be equal to 282. But let's use substitution to check our answer. So here's our original equation, W minus 102 equals 180. And we said, oh, it should equal 282. That's what W is. Oh, okay. Well, let's try it. So W I'm going to change. You said, oh, it's equal to 282. You got it. I'll change it right here. Let's see if that actually makes a true math statement. So I have 282, take away 102. 2 minus 2, that's 0. 8 minus 0, that's 8. 2 minus 1, that's 1. Oh, life is good because it says 180 equals 180. That's a true statement. That must mean our solution is, in fact, 282. Let's figure out this last part. To solve a subtraction equation, what did we do to both sides every time? This is the step I took. This is the step I took. So to solve a subtraction equation, add the same amount, not from, don't add it from, add the same amount to both sides. The goal is to get the what by itself? The variable. Get the variable all alone, just like we did here. We wanted W to be all by itself. We don't want any other stuff attached to it. All right, the last part of our lesson today, here's what I want you to do. You have your long-term memory chunk. I think it's 8 maybe. Long-term memory chunk 8. I want you to try to answer these two questions and then try to solve these two equations. You should probably pause for about 4 or 5 minutes before you come back and watch this video. Okay, what's our goal when solving an equation with one variable? To get the variable by itself. Huzzah! To get the variable by itself. How can we check our answer? We can use substitution. Use substitution. That's how we can get it by itself. And so now let's actually think about how we can solve these. So I want to get m by itself. It's an addition equation. So I need to take, oh, but look what I did here. Can I do that? Can I change 12 plus m into m plus 12? You bet I can. Order doesn't matter when adding. Order does not matter when adding. It doesn't. So I can switch it around. I'll do whatever I want. So now I want to find a way to make this equal to just m. So how could I do that? I could take 12 away from both sides. Whatever I do to one side, I have to do the other. These two should match. And so what's 12 minus, or 25 minus 12? That would get at least 13. 13? Double check. I can always check my math off to this side. 5 take away 2 is 3. 2 take away 1 is 1. Okay, so I'm good. Next one, y minus 10 is 8. I need to get this to somehow be equal to just y. Somehow, what could I do? I could take away 10, then I would have to add 10. But of course, if I put something on one side, I gotta put the same exact thing on the other. So y minus 10 plus 10, that equals y. 8 plus 10, that equals 18. So here's my solutions. My solution is 18 for this one. My solution is 13 for this one. The question is, do our answers make sense? Are they true solutions? Okay, so let's try it. Let's plug our numbers. Let's use substitution to go back in. 25 equals 12 plus m, and y minus 10 equals 8. So let's see how this would work. Oh, and this one's actually the same as before, isn't it? So we don't really need to check this one. But this one, let's check. So we said m should be equal to, we said it was 13, so let's substitute. 25 equals 12 plus 13. Well, what is 12 plus 13? If I add my 1s, I would get 5. If I add my 10s, I would get 2. And so this is true. And so that means 13 is a solution. 13 is the solution to our equation.